Hello everyone and welcome back to another problem of the day. And today's problem is titled Next Element with Greater Frequency. In this problem, you are given an array of n integers, and for every element, you have to find the closest element on its right that has greater frequency than its own frequency. So for the given example with 6 elements in the array, you have the elements 2, 1, 1, 3, 2, 1 itself. And for the output, you have 1, minus 1, minus 1, 2, 1, and minus 1. So for array of 0, that is for 2, the next element present to the right which has greater frequency is nothing but 1 because its frequency here is 3. Similarly for 1, there is no element which has greater frequency and is present to the right. That's why we have outputted minus 1 for 1. Similarly for this one, and for 3 here, the next element which has frequency greater than 3 itself is nothing but 2. That's why we have 2 in its place. So in order to solve this problem and understand how we'll be solving it, let's take in the first example. So the first example has elements 2, 1, 1, 3, 2, 1, 2, 1, 1, 3, 2, 1. Now if I had to basically find the next greater element, I would have to check for the frequency of each character. So first let's make a frequency map. So let's call it frequency, wherein I'll be storing the frequency of each character. So for 2, the frequency would be 2, for 1, it would be 3, and for 3, it's 1. Now using this frequency array, I'll loop over my array and check for every element after the current element. So for example, if my current element is 2 in this case, I loop over from I plus 1 to the ending point and check for the first element which has greater frequency than 2. So if I have j here, the frequency of j is nothing but 3 and it is greater than 2. So I'll have my result array and the corresponding value for 2 would be 1. Similarly, if I have 1 as my ith element, and then I would have to check for the elements from I plus 1 to the ending point, and that would be from j equal to 2 to n minus 1. And again I'll make the same check, and if I, for example, if I reach the end, then simply it means I would have to enter minus 1, meaning there was no element which had frequency greater than the current considered element. Now using this approach we'll be able to solve the problem only in O of n square, and they have asked us to solve it in O of n, and also the expected space complexity is O of n. This gives us a hint that we have to make use of some data structure or some form of recursion. So the data structure that we can use to solve this problem more efficiently is stack. And let's have a look at the algorithm itself. So let's consider the example again, which is 2, 1, 1, 3, 2, and 1. So this is my array. So similarly, we would have to calculate the frequency because there's no option to, without knowing the frequency, to compare the two elements. So I'll calculate the frequency first. So for 2, we have the count as 2. For 1, we have the frequency as 3. For 3, we have frequency as 1. Now, I'll make use of a stack. Let's call it S. Now, what I'll do is, I'll create a result array wherein we'll be storing a result and input all the array elements with minus 1 at the beginning. So for 2, it would be minus 1, for 1, minus 1, the minus 1, minus 1, minus 1, and minus 1. Now after this is done, I can simply loop over my array now. Now coming to the array at index 2, since it's the first element and the stack is empty, I'll simply be entering the index of this particular array element, which is nothing but 0. And y index will come to know as the algorithm progresses. So this is done. Now I'll simply move over to the next element, which is nothing but 1. Now I'll make a check if the frequency of this one, if it's greater than the frequency of my stack, the top of the stack. So here the top of the stack is nothing but 2. Is the frequency of 2, is the frequency of 2 smaller than the frequency of the current element? Yes, the frequency of 2 here is nothing but 2, and the frequency of 1 is 3. It is greater, meaning we can like correspond this 2's value to be 1. So what we'll do is we'll simply use this array index stored at the top of the stack and store the current index's value, that is array of 1 in this case, and we'll store the value of res of 0 to be, which is nothing but res of stack dot top to be 1. After this is done, I can simply erase this element because we have its value, and I can simply push the top of the stack with the index for the element 1, which is nothing but 1 itself. So coming to the next element, I have 1 again. Now again I'll make a check. Is the frequency of 1 here greater than the frequency of stack.top? No, it's not. So I'll simply be entering 1 again. Well, not 1, the index of 1, which is 2. Now after this is done, I'll again move my index to the next position, coming to 3. Now if I again make a check, is the frequency of 3 here greater than the frequency of array of 2, which is nothing but 0, 1, 2, greater than the frequency of 1? No, it's not. So I'll simply push the index of this array, this third element, this fourth element, which is 3. So it would be 0, 1, 2, 3. Now again I'll move to the next element within the array. So again I'll make a check. Is the frequency of 2 greater than the frequency of array of 3? Is the frequency of 2, which is 2 from the frequency array, is it greater than the frequency of stack stop, that is 3? Yes, it is. That means I can replace the value for the stack stop, which is nothing but at index 3, to be the value 2. So I'll use this index value, which is 3, 0, 1, 2, 3, and I'll replace this -1 with the value pointed by index I. Now after this is done, I can again check, since we got a value we got a frequency value which was greater than the frequency of stack stop. We'll again make a check after we remove the stack top. We'll again make a check, is the frequency of the element 2 greater than the frequency of array of top, which is pointed by index 2? So is the frequency of 2, which is nothing but 2 itself, is it greater than the frequency of array top, which is nothing but 1? No, it's not. So I'll simply be entering 2 in this case. Well, not 2, the index of this element, which is 0, 1, 2, 3, 4. Now again I'll move my I to the next position and I'll make a check. Is the frequency of I greater than the frequency of stack.top, which is nothing but the frequency of I here, which is 1. It's 3. Is it greater than the frequency of stack.top, which is nothing but 2? Yes, it is. So I'll simply replace this index value, that is 4, which is present at this position, with the value pointed by I, which is 1. Now after this is done, my I comes to the end of the array and we break out of the loop, and the resultant vector or array is our final result. And all the -1 present here are simply for the elements which have no greater elements present at the top of the stack. So that is how we'll be solving our problem. And the effective time complexity of this problem would be O of n, since we are only following one loop, and at any point we will not be exceeding O of we can perform O of n operations within the stack, but that would be only one. So our effective time complexity becomes O of n, and the space complexity, since we are using stack frequency and res of the same size, it becomes O of n effectively. So let's jump right onto the code. So first of all, as discussed, we'll be creating a stack wherein we'll be storing the indexes. Let's call it S, and next we'll push the first index within our stack, because there has to be the first index. We will be starting a comparison from the first index, so it makes sense to push it first. Now we'll create a vector array, vector result, wherein we'll be storing the effective results, and it would be of size n, and we'll pre-fill those vector positions with -1, and we'll create an unordered map in order to store the frequency. After this, we have to calculate the frequency, and for that we'll have to make a loop once from 0 to n, and we'll use the array element and increment the frequency as we go. So after this is done, we can simply begin our main for loop, wherein we'll be making the checks and using the stack. So it will be from index of 1 to n. Now first, there might be a case wherein let's say my frequency array, the frequency of array of top, which is nothing but 2, its frequency, well, it's not greater than the frequency of the current element. So in that case, I'll simply be pushing the element to my stack. So we'll make a check if the frequency of array of the stack stop, if it's greater than the frequency of the current element, which is nothing but array of I. If that is the case, we'll simply be pushing the element onto the stack, and we'll be pushing the index itself and not the element. And within the else block, we'll make a check. Since within the else block, it means that our frequency here for the array top, it's less than the frequency of the uh, current element, meaning we can consider this element to be our result. So in that case, we'll loop over our stack till the stack is not empty, because at any point there could be a case wherein we have an element which has frequency greater than all the previous elements. So in that case, we would have to pop all the elements which are present in the stack. That's why we have to make this check in order to avoid any exceptions. So if this is empty, and we'll also check if the frequency of the stack stop, which is s dot top, if it is less than the frequency of the current element. If that is the case, then I'll simply be replacing the result for that top element to be the current element, and we'll pop that element out of a stack. After popping, we simply have to make this push again. Well, not again, we have to make this push to make note of the previous element. And after this is done, we can simply return a result. Let's try and compile. All right. Alright, so that was it for today's video. If you have any doubts or suggestions, you can ask them in the comment section, and thank you for watching.